Okay, well, welcome everybody to our webinar. We are the VU Summer Campus team. First check, can you hear us well? You can just type into the chat. Yes, perfect, great, thank you. Okay, so this is the first time we're doing this now, and we're happy to have so many of you participating. What we'll do today is I'll give you a quick introduction of who we are, and then we'll dive into the results of the first quiz. Okay, so my name is Dieter. I'm the project manager for the VU Summer Campus 2019, and together with me here is a competent team of tutors, and they will one by one introduce themselves quickly. You've probably seen them or interacted with them online on the campus. Let me start here.
Yeah, so my name is David. I'm a master student in marketing, and I'm one of the great teachers, I hope. And I'm happy to assist you with all the questions. With the buttons on the below on the screen, you can use the Q&A button to ask questions about math or anything else.
My name is Fons. I'm just finished my second year of econometrics and data science. I'm also one of the tutors. And if you have another comment, that's not a question, you can just type it in the chat, for example, if you can't hear us or something. And if you want to ask a question that you can type in the Q&A, you could just raise your hand and we could let you talk.
You see the controls down there, right? Just like the way Floor is stitched. Okay.
All right. So I'm David. I'm a third year business economics student, and I'm doing the quiz stuff right now. And in order to kind of get a nice feeling for how it's going to be in the first year, I think it's a nice introduction for you guys to get familiar with the math. This is a good start.
Yes.
Yeah.
Excellent. So what you're seeing is we have two Davids.
Yeah.
Get confused. And in fact, once you arrive at the VU in a month, or actually less, you'll probably figure out where we are. You'll come here across quite often. And next week, we'll pick another space to show our webinar. Okay. So then we dive right into the questions. David will walk you through everything. Don't forget the controls. Raise your hand, put something to Q&A. And oh yeah, the whole meeting is recorded. So if there's something we speak too fast or you don't understand, it will be posted on Canvas. You can follow that and then just rewatch the entire thing. Okay, cool.
All right.
Let's get started.
All right. So a few things I want to say before we start.
A bit closer, I think.
Sure.
And then wait, you're sharing?
Let me see.
We're sharing, right? Yeah, okay.
Yeah. So I hope the first quiz went well for all you guys. It was not very hard because if you really couldn't figure it out, you could just plug it in a calculator and just find the answer. But that's only for the first quiz. The first quiz was basically that. But for the next quizzes, you can just plug it in a calculator anymore, and you have to do it by your head. So what I'm going to do right now is I'm going to go through the questions that were the most difficult for you guys, and we kind of had to different answers. And it's going to be like 4 questions. So let's just start off with question 6. This was one where you already kind of had different answers. And to start off with, simplify.
Slightly speak up. I think the camera's a bit far.
Oh yeah. Okay.
Perfect.
Can you hear me? Okay. So the first question, question 6, was simplify as much as possible, and where we had this kind of 2 particles. I'm going to highlight them right now. So this and this. And how are we going to tackle this problem? Well, we got 2 particles, and we should start with something that's between the brackets always. That's like the first rule. And so what we're going to do is like get this equation to that side, and we're going to split them out. So we know that 2, 3, 4. We let this remain the same. Yeah. But on the right hand side, we're going to put this into one fraction so that we can later add it up. Okay, so what we see right now is 5/12 in the first fraction, but we have to make the second fraction also for the same kind of number in the denominator, which is also 12, so that we can add it later on. But in order to do that, to make it to 12, we have to, we have to do it times something that is still equal to 1, 1 divided by 1. But how are we going to do that? Well, we are going to everything times 6, which is still 1. So this kind of fraction does not change. We just rewrite it in simpler different stuff. So work it out. This times this times this, and we get 2, 3, 4 minus 4. Yeah. We get 5 minus 12. Yeah, and we can add these two together, which is minus 25, 12. Okay, once we got that, we're going to solve for this whole right side. And it's going to be 2, 3, 4 minus 1/3 times minus 25. We see right here, but let me make some more room. Which button was that?
Actually, just zoom out a bit.
Zoom out.
I'm going to move it.
Oh, okay, nice. So I'm going to continue on the right side. This is equal to, it's going to be a big one. Let me see, 2, 3, 4. So that was the same. Plus, because we do minus times minus, which is a positive thing. And then we 1 times 25 on the numerator is still 25. But on the denominator, 3 times 12 is equals to 36. And then what we have to do is we have to add the first and the second fraction. Yeah. But these two are the same in the denominator, so we have to make it equal to on the lower side. So what we're going to do is we make it 4. We try to make it, 36 out of it, so that we can add them later on. But we have to make this a whole fraction first. So how are we going to do that? We're going to put the 2 inside the 3/4. Now, simple. Put 4 down here. But how many 2's fits into 4? What do you think? 2, 3, 4. Oh. This is equal to 8 plus 3 divided by 4, which is equal to 11/4. Can you see why this is like right? Because I can take 2 2's out and then you leave out 3 behind. So in order to continue, excuse me, this is 11, 6 plus, let's see, plus 25, 46. Now we add these two together and come right. Wait a second. 6. Okay, I'll probably make some kind of small assumption that's probably not right. Let me figure it out.
Yeah, you took 5/2 instead of 3/2.
5/2. Oh, okay. Yeah, it's oops. But the principle is still the same. I took 3, and then this was 18, and then let me see. Well, this won't be 5 anymore. This will be minus 13. 13. Sorry, yes. Okay, plus 13. If I'm right. 13. Okay. 6. But it's still not right. Okay, wait. Give me 1 second.
Yeah, of course.
Okay.
Maybe one of you has a suggestion where the
Yeah.
mistake is.
Do you see?
Oh yeah. You have.
Yeah.
This should be 11/4.
11/4. Yeah. Oops. It's early.
So this is a live performance, as you can see.
Yeah. So you see, it's not fake anymore. Yeah. Okay. Yeah. So to work this one out, so we had 11/4, and we have to still turn this into 36. So what we do is like we try to make the denominator equal. We do that by time 95 by 9. You see why? It's still 1, but like at least it makes the lower side equal to 36.
Yeah.
Yeah. And we do the same for above, would be 99. And we erase this part. Messy. Okay. 99 divided by 36 plus 13 divided by 36. And this will equal a very huge number. Let me see. Maybe 12, 36. Right? Let me see. How many can we take out? 12. Second. Okay, we're going to make a quick thing right here. I'm going to take out 3, which is equal to 128, 4. We keep. Okay, so what I've done here is just a simple partition, like myself. You can do it too. So basically, what's coming out is we can take out 3, and we leave out 4 and 36. Oh, 46. And if we simplify this one, we divide everything by 4. We leave out 1, 4, 9. So the solution will be 319. If I'm right, which was this one, which is the right answer. So if you had that one, right. Okay.
Okay, great. So we have 4 questions in total.
4 questions, yeah.
Okay.
Do you guys all understand what David did, or do you have any questions left? Then let us know in the chat.
If you send a question in the chat, make sure you can select to all panelists and participants so everybody can see. But the best way is to use Q&A for that.
Okay. The second question was question 10. Write the expression. Did you have to say something?
No, yeah, there are a lot of questions about the calculator we can use. If they're allowed to have a graphic calculator or just a normal one. So maybe you can clarify that a bit. And then
If you mean for like this quiz, for the first quiz, yeah, you sometimes had to use maybe for first or second question the calculator. But from the next quizzes on, you don't have to. You aren't allowed to use the calculator anymore. If you mean for the course itself later on, you don't. I don't think you have to use. You don't get to use a graphical calculator. It's not allowed. But you are allowed to use a normal conventional kind of calculator.
I don't know how it was for you guys, but in my case back then it was whenever you're allowed a calculator, it doesn't really help you. So for if you can, try to use it without.
Yeah, and I think it's also good to try to practice without calculator because at the end you have to use with variables with x's and y's, and then you cannot just plug it into a calculator. You just really have to get familiar with doing it by your head. Okay. So to continue with question 10, write the expression square root 4 divided by square root 3 to the power 5 in standard notation. And yeah, it was quite a big power, right? You can just go, well, okay, this, 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 up. But that's like really cumbersome, and you're going to lose a lot of time to do it step by step like that. So what I do is a bit simpler, I think. I try to go there, split this up into smaller kind of things, but I leave one square root for one element. I leave it out like this. It's still the same as the original kind of term, but right now what we see right here is we can rewrite this first one, the first term, and we can rewrite the second term. Now, how are we going to do this? We know that square root 4 is equal to square root 4 to the power of half. And we know that 3 is also to the power of half. And we do that to the power of 4. What we do with the second term is we have square root 4 divided by square root 3. We apply the same trick as we did with the previous exercise. We multiply this one with square root 3 divided by square root 3, which is still 1. But then again, we can eliminate this in the denominator, this 3, this square root in 3. Yeah. So to continue, once we've got that, we are going to. This is something that's maybe new for you guys, but you have to apply a certain rule if you do something to the power of something. I'll explain it now. Like 4 to the power of half is to the power of 4 is equal to 4 times a half times 4. And the same applies to 3. This is equal to a half times 4. And this rule is very important to know because for the variables, for x's, later on you get something like that too. And you have to apply the same principle. That's really useful. And this was the first term what we are doing. Now we're going to the second term. And we just broke this one out. Square root 3 times square root 3 is 3. Square root 4 times square root 3 is square root 12. And then we're going to continue with this. And what we see right here is, okay, we do this times this is 4 to the power 2. This times this is 3 to the power 2. And we just this was the first term again, and now we're going to the second term. And we can see that we can leave out 1/3 times square root 12. We're almost there. We have to work these powers out. So 4 to the power 2 equals 16. 3 to the power 2 times, let's see, is equal to 9. But we still have to solve for this one, for this 12, because it's way too big. We can simplify it much more. So we do times 1 third times square root 4 times square root 3. See, we divide these 12 up into smaller fractions every time with these. And then we can see right here is we are going to take this to the upper hand side, and we know that square root 4 is equal to 2, square root 4 is equal to 2. So we know that 16 times 2 times square root 3 divided by 27. And this is equal to 32 divided by 27 square root 3. You see what I do? And then we go back to the answer. You see that this one is right. So it was exactly the same as this one.
No questions?
No questions?
All right. So we're planning for this whole thing to be half an hour, so no worries.
Yeah.
How much do we have left?
2 questions.
They
They
are
are
straight. Great.
So, and now we go to question 11. I saw that a lot of students were, kind of confused how to use this operator, especially these brackets. These brackets are what I call absolute values. As in, if something is between these brackets and it's negative, like say, for instance, minus 3, what this means is it's not just minus 3. These brackets make the whole thing that's between the brackets positive. So in the end, you will get 3. The same is applied for this question right here. Calculate 3. If you, try to solve this one, I assume you've all noticed how you can do this one between the brackets. It's just calculating what's between these two. But you will see that the solution was minus 6,062. And some of them were like, okay, now I'm finished, and then just fill that one in. But that's not completely right. You have to make this positive, and then it becomes 1,062. So you were almost there, but like only make it positive, and then you were right. So this solution was right. Great. And then last but not least, question 12. This was an old midterm question from QRM and also other statistics, mathematics courses. And what we see right here is that, yeah, it's kind of basic, like 1/5 times this. But the skill right here is to, not to try to put it in the calculator and try to, you really have to do it by your head and do it step by step. So I'm going to do this step by step. 1/5 times square root 125. And what they wanted right here was, to just try to split this square root 125 up into smaller particles. So they kind of use the principle of x times square root x is equal to x. I think that's the easiest way to handle these kind of big square roots. So what we can do is, we try to find as many kind of same kind of numbers so that we can cancel out these square roots. So what we do right here is, it's just a trial and error process. You can't just, know it immediately. You have to do it step by step. And you know that, for instance, 125, we can split it up into 5s maybe, because it's divisible. You can divide it by 5. And if I do that, this, square root, oops, square root 5, square root 5, and we just go as long as we, you know, 5 times 5 is 25 times 5 is, yeah. It's kind of cumbersome what I'm doing right here, but it's a way, it's a step. If you know one better, it's good for you too. Yeah. So what I did right here was, you know that 5 times 5 times 5 equals 25. Oh, how many do we have left? Oh, we still have to do it times 5 so that it becomes 125. So in that way, we know that, okay, we have to do 3 square roots of 5, and then, you know, we know that these two cancels each other out. This becomes 5. So we get 5 divided by 5, which is equal to square root 5. And then we know that this one was right.
I could maybe add something here. I mean, the way you explain it makes perfect sense. I think as I can use another color maybe not to mess with yours.
Yeah.
Let's take. If you know that it ends with a 5, then it must be divisible by 5, right? So you can just go step by step. So just say 5.
Quickly not touch the. Your hand touches. Yeah.
Okay. 5 times something. What is it? 125 is the same trick as David used before. You just take out 5, and then you're left with 5 times 25. And then you can do the same trick again, and you see it's 5 times 5 times 5. So you can go step by step if you don't know the answer right away. But that works perfectly, and yeah, excellent.
All right.
If you have any question, now is the time.
Yep.
Otherwise, we'll make the recording available. And if you have any other feedback on the way we do this, is it too slow, is it too fast? Don't hesitate, let us know.
Yeah.
Yep.
Anything else? Were there any other questions in the Q&A?
Not yet.
Nothing else?
Oh, question.
In the chat or?
Yeah. So one of the questions is when the next quiz. What is it all about? The next quiz.
Yes. So we're going to use a lot of variables, and you will see that this quiz is soon open. Once we open it, you will see like a list full of topics we are going to explain. But basically, we're going to put in more equations and that kind of stuff. Yeah, more kind of the algebraic kind of stuff.
Yeah, and I think the next webinar will be a lot harder for the equation part. So it will be great if you could attend the webinar, and it's I think a helpful way to get the right steps.
Yeah, and maybe a last note, all these kind of questions are at the level of midterms. Some of them are at the level of the real exam. So if you can keep up with this level, I think you are going to be fine.
Definitely, yeah.
So,
So yeah, so next week's going to be algebra mostly.
yeah.
Okay. If there are many questions, and you want us to discuss a particular one that you're struggling with or you don't understand, let us know. Then we'll spend extra time on that one.
Flores had a question, but I'm not exactly sure what you mean.
Can you read it out?
Yeah. Why is it 1/5 times the square root of 125 instead of 5? What exactly do you mean? Because 1/5 times the square root of 125 is the question of the quiz.
Well, can you see the question? Is he?
Yeah.
I know, like his question, Flores is in, because
It's
I
in the
don't
chat.
see it in the chat for some reason.
Okay, you already understand.
Okay.
Perfect.
Yeah, because in this question, I think if you just put it in the calculator, you get out some decimal number, right?
Yeah.
And that's not what you're looking for. Because the decimal number is just a representation of square root of 5. So in the exam, I guess if you give out, I don't know what it is, 3 point something something something, you won't get the full points. Okay. Last chance to.
Understand.
Can see
Any more questions?
No, can't see any.
No, me neither.
Okay, great. Then thanks everybody for attending, and we'll see you on Monday for the next webinar.
All right.
Thank you.
Thank you.
Thank you.
Bye.